Okay. All right, I just started the recording window as well, so that anything that we work on today will be recorded for people who can't make it live. Now, the things that I wanted. This section is all about confidence intervals. So there are a couple of pieces to confidence intervals. There are some homework problems where you have to pull values of t in order to construct a confidence interval, and there are portions where you're constructing a confidence interval. So the easiest way to actually do the construction of the confidence interval is to use the calculator features for the confidence interval. The actual calculation is not real labor intensive, but the calculator will give you all of the values you need. So we have on the calculator, you have a menu under the stat button to get to your confidence intervals. So if you were working on your calculator and you're constructing just the confidence intervals, let me click on my pen. And you're constructing just the confidence intervals, the things that that you will need are all under your stat and then test button. So if you press your stat button and then scroll over to tests, options on the calculator are option number 1 for option number 7 for a z interval. Option number 8 is a t interval. And then option A is a 1 proportion z interval.
And that one I got.
Okay. Those are the 3 that you really need for this section for chapter 9. We're going to expand in chapter 11 all of the intervals, but these are the 3 that you need for this one. So if you have a proportion, so if you're working with a population proportion, then the one that you want is A, the 1 proportion z interval. Now, if you press that button, A asks you for a number of things. What it asks you for is it asks you for a value of x, it asks you for a value of n, and it asks you for a confidence level. So if we're working for this problem, then our x value would be 180, our n value would be 30, and our confidence level for 99% would be 0.99. And your calculator will do the construction of the upper and lower bound for you, and just using that button. So what it gives you for your display is it gives you the lower bound, 0.52714 is what it gives, an upper bound of 0.67286, and then it also gives you a value of p hat. Now, this is helpful because some problems will ask you for a point estimate, and that point estimate is your p hat value. So p hat here is equal to 0.6 for your confidence interval. So if you're constructing a confidence interval for proportions, this is the process on how you do that. Now, if you are asked for a value of z that has to do with that, then we use the inverse normal function in order to find values of z. So for example, let me pop up some additional space here. If we want to find the value of z for a 99% confidence interval, what we use is the inverse normal function. So the calculator function is inverse normal, And it's under the distributions, and it's number 3. On distributions. And what it asks you for is an area. Now, finding that area, when we're constructing a confidence interval, we are looking at, if I want a 99% confidence interval, then I want 99% of the area in the center of the distribution. But the inverse normal function is set up to work with the tails. So what you have to be able to put in is the 1 minus alpha over 2, this value here. So this is 1 minus 0.99 all divided by 2. And that's the area that you have. Now, Sherry, your calculator had an option where it asked you if it was right-tailed. Is that right?
Yes.
Okay. You must have a newer calculator than me because I don't have that option. It just gives me area. It doesn't give me right or left-tailed. We use positive values for construction of our confidence intervals. So if you have that option, you want the right tail. If you don't have that option, like me, I must have an older calculator. They're changing the menus on these calculators all the time. If you have a calculator like mine that doesn't give you a choice, you have to choose a positive value for the value that your calculator gives. So that area, the 1 minus 0.99 over 2, is 0.005. And then also part of that menu, it asks you for mu. Mu is equal to 0. Sigma is equal to 1. So those values will then spit out what your z value would be if you were going to calculate this problem by hand. And I get from the calculator 2.576. It's like 2.575829, so to 3 decimal places, 2.576. Okay, questions so far? Okay, all right. All right, so moving on to the other type of problem in the proportion section. So we also have problems that have to do with sample size in the proportion section. So if you want to estimate the percentage of adults who, for this one, support abolishing the penny, what sample size should be used if he wishes to be within 3 percentage points of the actual value with a 99% confidence interval. So there are 2 different formulas for sample size, and the first one is if you have a prior estimate. So if we have a prior estimate, then n is equal to p, whatever that prior estimate is, times 1 minus p times whatever our z-score is for 99%, divided by our margin of error squared. It's just that last piece that's squared, but this is our actual calculation formula for it. So in this case, when you are trying to do a sample size, you do have to get that value of z first. So I'm going to change this to like 95% so that we're not looking for the same value of z. But if I'm looking for a 95%, then what I'm going to do is that's 95% in the middle. So 95% is here. And what I'm going to plug into my calculator is that 1 minus 0.95 over 2, or 0.025. So the first step is that inverse normal with an area of 0.025. Mu is equal to 0, sigma is equal to 1. Which gives me a value of z equal to 1.96. So then moving on to actually calculating the n value, n in the first part of this problem, we're using a previous estimate of 25%. So n is equal to 25% or 0.25 times 1 minus 0.25. The z value we pulled from our calculator, 1.96. And then the error on the bottom is where you want to be within. So 3 percentage points, or 3%, or 0.03. And it's squared. So we plug that into our calculator. 0.25, 1 minus 0.25, and then 1.96 divided by 0.03, and that last piece is squared. Gives me 800.33333. And this sample size is actually one of the places in statistics where we don't follow traditional rules of rounding. So these are always rounded up. Reason for that is because this is a minimum sample size, so 800.333 is the minimum number you can have. So if you rounded that down to 800, then you're below the minimum, so we can't use that 800 value. We have to round up all the time. Now, the only difference between having an estimate, having a prior estimate, and not having a prior estimate is that no prior. What we do is we eliminate this front portion and replace it with 0.02 or 0.25. So n is equal to 0.25 times the z over e squared. So the thing, it is really the same calculation, and we replace it with 0.2 or 0.25 because we're using a p-value of 0.5. But those are the replacement values there.
Yeah, so I was getting that in the reading, except for I was like, you kept talking about a t-table, but
we do use the
t interval 8 instead of the 8.
Okay.
Okay.
The t interval we use for means, so we do use the t interval, but not for proportions.
Okay.
Those are going to be means problems. Let's go over a couple of means problems, since that's the one I think that it seems like you're struggling with more. If you're looking at problems that have to do with means, there are two different types of intervals. One is the z interval and one is the t interval. So if you are given x bar and s, anytime you have x bar and s, then you should use the t interval. If you're given x bar and sigma, then you can use a z interval. In real life, we almost never use the z interval, but you can if you're given a sigma or a population standard deviation. Most of the time, we're using a t interval. So you can use either the t table in order to find values of t, or you can use the inverse t function to find values of t. So t values, inverse t, and if you go to your inverse t function under your distribution, it's going to ask you for area like the z one does. So this is area in the tail again. It's going to also ask for degrees of freedom. And we find degrees of freedom by using n minus 1. So if your sample size is 24, for example, your degrees of freedom would be 23. And that's all you need for the inverse t, and then your value you get out of there. So if we're looking for a 96% confidence interval, for example, if I need to find the t value that goes with the 96%, then we're using the same calculation. So we're going to do 1 minus 0.96 divided by 2. So 1 minus 0.96, divide that by 2, we get 0.02. So our area is equal to 0.02. Our degrees of freedom, if we're using that first one, degrees of freedom here would be 17. Degrees of freedom equals 16. So n minus 1 gives me 16. So the t value that I need for that, 0.02, 16 degrees of freedom, would be 2.235. Now you only need to actually find your values of t if you're asked for what is the value of t. If you're just asked for the lower bound and upper bound, then we're going to use the t interval button. So that's under stat and tests, and it is option number 8. And it's t interval. And it asks for the following things. First, you have to decide whether you want to use it with data or you want to use it with stats. If you're given X bar and S, you're using stats. If you're given a list of values like 5.21, 4.70, etc., then you're using data. So if we choose stats, then it's going to ask you for X bar. And in this example, X bar is found to be 112. So we have 112. It's going to ask you for SX. And in this example, it's equal to 10. And it's going to ask you for your sample size. So for this first one, we're using 17 for our sample size. And then it's going to ask you for your confidence level. So we want 96%, so I'm going to put 0.96. And then it calculates. So your lower bound here gives me lower 106.58 and then upper 117.42. So these values are ones that come out of your t interval from your calculator. Questions on calculating these? Okay. If instead of having your summary statistics, if instead you are given, it's another with, sample size. If instead you are given a list of values, there is one in the homework where you have a list of values, then you would use the list feature. So if you have data, enter your data into L1. And then when you go to your t interval, choose data. When you go into your t interval and you choose data instead of your stats, it asks you what list you want. So you would put L1 here. The frequency, this is always going to be equal to 1. And then your confidence level again. And then it'll calculate for you from there. So that's the other way in order to get a t interval. Okay, the other type of problem on here is looking for a minimum sample size when you have a t interval instead of a z interval. So if you're looking for minimum sample size for a t interval instead of a z interval, then let me look at my, hold on one second. Here we go. Then I'm moving over the formula sheet for the course. We are currently in estimation. So if we are looking for a sample size where we have means instead of a proportion, our sample size calculation is this one. So ZC times the standard deviation divided by the margin of error all squared. So that's the calculation that we're going to use for a minimum sample size for means. Proportions is this one that we already used, but if we're doing minimum sample size for means, that is our sample size calculation. All right, so a sample size. If a doctor wants to estimate the cholesterol level of 20 to 29-year-old females, how many subjects are needed to estimate the mean cholesterol level within 4 points with a 99% confidence, assuming the standard deviation is 11.8? And then if we're looking for that. So our sample size is equal to, if we're given a population standard deviation, we use Z times sigma over our margin of error squared. If we're given a sample standard deviation, then we use T times our sample standard deviation. And our error squared. So we have a 99% confidence level, so I'm going to bring the t value for that confidence level. Using all of these problems also have a table, and if I'm looking at the t table that comes up, we can use values of z or t based on this particular table. So if I'm looking for 99% and I don't know what the sample size is, then what I'm going to use is 2.58 from the t table here. So this is my value that I'm going to use. So looking for n is equal to click into that pen again. N is equal to 2.58 times our standard deviation from previous studies, so 11.8. Our margin of error is within 4 points, so here 4, and it's squared. Again, because we're using a sample size, we always round these up. So we would need at least 58 for our sample size. Okay, so this is kind of a basic overview and addresses most of the questions that I've been receiving by email this week. Do either of you have any specific questions that you'd like to go over?
Not yet. I gave up.
Okay, so I know you've sent me a couple this week that I've sent you back instructions for,
Yes.
and if you run into any more, I'm more than willing to send you back instructions if you run into any throughout the rest of the week. Do you have any as well? There are 2 of you on here. Okay, all right. I'm gonna go with no then. All right. Any further things that you want to see?
I don't know. Got to get going on it. Kind of gave up and hit a wall. We wanted to wait until this to try to get this homework.
Okay. All right. So this is a basic overview. Do you have your calculator with you?
I do.
Okay. Have you been going through and making sure that you get the values out that I've gotten here?
Yes.
Okay. All right. So you've been successful so far?
Yes. do the whole like divide it by all the steps. I just have a problem remembering which steps to do. Like find the C first, or
Okay.
You know, look at a problem and it goes do this, and I'm like, oh, I'm totally. I just did something else 5 minutes ago that was exactly the same, and it's just gone. You know.
Right. And there are, we have 3 different ones to choose from, and the differences between them are really, they can be pretty subtle. So, so using the proportions. So if we're dealing with proportions, then going down to hit this option A, versus if you have means, then you have to choose between the t interval, or the interval for t and the interval for z. So the decision making part can be probably the biggest challenge of this, because the calculator does most of the actual computational work for you, but you do have to press the right one in order to get the right answers out of the calculator. On that note, if you are in the e-learning course, there is like the midterm had a formula sheet for it. There is also a formula sheet for the final exam, and the final exam formula sheet is this one. So the nice thing about the final exam formula sheet is that when we're in the estimation section right here, right now, and if you are looking at the formula sheet for the final exam, the confidence intervals, if you know sigma, like sigma is known or given to you, sigma, remember, is that population standard deviation, then you should be using a confidence interval for z. Versus if you're given a sample standard deviation instead, then that's when you use the confidence interval for t, and the confidence interval for proportions are always separate. So if you are looking at this formula sheet, it can help you determine, well, what information are you given in the problem, and then therefore what button should you choose on the calculator. So it does work a little bit like that, and hopefully that'll help with the selection process.
So this 4-page formula sheet will be given. I thought that's what it said in the directions. I was
yeah, that
I've been trying to use those, but
yeah,
still.
The 4-page formula sheet will be part of what you get for the final exam. The binomial table is the same one that was on the midterm, and you'll also get a copy of the z table and the t table in case you want to pull your values from the tables instead of your calculator. So those will be your options to choose. But that formula sheet will be provided.
Gotta remember put in what formula.
Yeah, it's there. By the time we get to the end of the course, there are a lot of different formulas and different processes to remember on your calculator. And during that final, the week leading up to the final exam, I will have probably this session plus another session on just how to know what to do when. So that's really the hardest part, because there's so much information, and choosing what process to use for each individual problem can be challenging.
Yeah, and it is cumulative, right?
Yes. Yep.
You're starting to have to remember vocabulary from the first.
Well, everything that's on the midterm will be lessened for the final, so there will be pieces of it for the final, but it won't be as weighty. For the final exam, I've included a review as well as a practice final, so you can get an idea of how long it'll feel, and take more than one practice version.
Is there more than one on there? Because I think there was only one midterm.
There's for the final, there's listed on the final exam review session. There is a final exam review, which is long, and includes all of the topics, and then there's a practice final, which is more representative of the actual length of the final exam.
Okay.
So 2 different ones, yeah.
Good. That's good. Okay. Well.
All right, well, definitely let me know how I can help further. Melissa and Erica, I see that you just joined. Did you have any particular questions that I can answer? We went through kind of an example of each type of problem for this week, and I'm recording this, so I will post this after the session is over, but I'm more than willing to answer any questions that you have as well. I'm always unsure if silence means no questions or if silence means I can't get my microphone working, but I really have a question.
I don't have any idea what to ask. How's that?
Okay. All right. Well, if more questions come up, or as you're working through the rest of the sections this evening, or when you're working on them, just drop me an email. Let me know. Post to the message boards. I check the message boards at least a couple times a day. So if you post there, I will also address them there.
Appreciate that.
Okay. Well, I'm done with content. If you guys are set.
All right. Have a good night.
All right. You too. Oh. All right. Thank you. I got the chat post.